Galaxies, galaxy clusters and galaxy superclusters, the cosmological principle. The immensity of the observable universe is simply mind-boggling. Yet, at present, we really have no idea of what proportion of the whole universe the portion we observe represents. Recent theories of the origin of the universe suggest that the vastness of our universe might be an infinitesimal grain in a multiverse, i.e. the set of all existing universes. Edwin Hubble's work was the first to give astronomers an idea of the immensity of the universe. Working on Mount Wilson in the 1930s with what were then the largest telescopes in the world, Edwin Hubble took sample photographs of the sky in many regions, about 1,283 areas, and counted the number of galaxy images he could detect on his photographic plates. From his survey he constituted a map with our galaxy, the Milky Way, across the middle of the plot and what came to be termed the galactic equator. The top and bottom of the map are referred to as the poles. After having corrected for the dimming effect of obscuring clouds of dust when observing the sky in the direction of the Milky Way, Hubble concluded that on the large scale the distribution of galaxies is isotropic, i.e. galaxies are uniformly distributed around us in the sky. Hubble's observation led to the view that our universe is homogeneous, that is, the same in all directions and at all distances. The idea of isotropy and homogeneity of the universe is termed the cosmological principle. The cosmological principle remains the underlying assumption in cosmology. Observations by astronomers of the distribution of galaxies in large slices of sections of space have shown that our galaxy is a member of a small group of galaxies called the local group. The local group is about 3 million light-years across and contains at least 26 members, 3 large spiral galaxies, 9 dwarf irregulars, 2 intermediate ellipticals and 12 dwarf ellipticals. Other galaxy clusters have been detected beyond ours. The nearest observable from our planet is the Virgo cluster, a system consisting of thousands of galaxies. Yet another galaxy cluster larger than Virgo is the Coma cluster. We can detect these particular clusters because they have densely packed galaxies whose brightness stand out against the backdrop of other galaxies and clusters. It is believed that there are several smaller galaxy clusters closer to us than Virgo and Coma which we cannot observe against the background of light from other galaxies in space. Astronomers have further discovered that there are even clusters of galaxy clusters. A discovery of great interest to astronomers was the fact that between these galaxy superclusters on immense stretches of void. Studies of our local supercluster of galaxies, of which Virgo is the most prominent, reveals a local supercluster of mostly empty space. Most galaxies belong to local clumps which together occupy only about 5% of the total volume of space in a local supercluster 60 million light-years across.